Welcome to the Java implementation of the queue. So in this video we'll see how to implement queue out of two stacks in Java. Okay, since we are going to use stack Java collection class called stack, so we'll be importing java.util.stack. Then Java stacks, actually they internally store only objects, so they don't store any primitive data types. Okay, so we'll make our class as public so that we have a main as well as part of this class. Okay, so we would have a old stack and new stack as private members, right, which takes integer objects. Whole stack, then private stack which stores integer objects, new stack. Okay, and we would also need a top element. Okay, and we would also need a size to store the size of the queue, right? And then we'll have a constructor. In the constructor we will initialize old stack equal to new stack, and new stack equals new stack which stores integers. Okay, fine. We'll have to initialize top element to -1, and we'll do the same thing for size. Right, we are good here. Now let's try to implement the enqueue function. So there is no destructor concept in case of queue. Of course we do have the finalize method, which is not required here. Okay, so we'll go with the enqueue functionality. So public boolean enqueue which takes a element. Okay, and over here we'll have a boolean for the return. So let's say it is initially true. Okay, there could be exceptions, so we would wrap with the try catch blocks. Okay, and we are going to push the entry into the new stack. Okay, over here there is one small correction. So what we need to do is, the Java stacks actually only stores the objects. They don't store any primitive data type like integer. So what we need to internally do is, we need to wrap that integer within a integer object. We can do like this. We are using anonymous object here. Okay, so we have constructed an integer, and then we are passing that integer, we are pushing that integer. Okay, in case of any exception, right, so we can catch that exception probably. Over here we can say, we can mark return as false. Okay, and probably for the user we can also print something, print some error message, right? So we can say some error occurred. Okay, good, and we can return the return over here. Fine. So we are done with the enqueue. So we'll try to implement the dequeue functionality. Dequeue. So dequeue doesn't take any parameters. Okay, so we have we'll initialize the top element to -1. Of course this is initialized to -1 in the constructor, but we'll ensure that it is initialized to -1, right? So now we need to check if the whole stack is empty. If whole stack is empty, only then we need to fill the whole stack, right? That's what we discussed in the first part of this video, right? When this is empty and while new stack has some values. So while new stack is not empty, right? So what we could do, we could use the top element here. Top element equal to new stack dot peak. Peak is similar to top in C++, so which would return the topmost entry from the stack without removing the entry from the stack. Okay. Otherwise, rest are same. Okay. So we have this topmost element and the top element. Now we need to push that entry into the old stack. So old stack dot push top element. Okay, we are done. So now we need to remove that, pop that entry from the new stack. We are done. And now at this point we need to retrieve that topmost entry from the whole stack, and we need to return that, right? So before that, we are checking if whole stack is not empty. We come over here, we retrieve the topmost entry like this, whole stack dot peak. Okay, so over here again there is one change, right? So peak would return an integer object as opposed to primitive data. So let's accept that value in a integer I. Now what we could do, so we could actually in fact actually we can we are going to return it, right? We are going to return a primitive integer. So what we need to do is we need to say top element equals to I dot int value, which is a function exposed by provided by integer class, integer object. Okay, so far so good. And we also need to pop that entry from the whole stack dot pop, right? So now we have that entry in the top element. Okay, we can return the top element. In fact, actually there is a possibility that there could be some exception, especially parsing exception or something of that set could happen within this loop. So it's a good idea to perform a try catch here. Okay. Okay, we are done, and we'll move ahead with the isEmpty function. Public boolean isEmpty. Okay, isEmpty, we need to check the emptiness of both the stacks, right? Whole stack is empty and new stack is empty. Then we know our queue is empty. Otherwise, we know our queue has some value. We can return false here. Okay, and we'll see how to implement the size. Okay, so over here we need to check retrieve the size of whole stack plus retrieve the size of new stack. Okay, we're done. So now we need to return that size. Okay, so now let's see how this can be used, how our queue can be used. Public static void main, which takes a string arguments, queue equal to new queue. Okay, so over here we'll have a loop for, so let's say, what is whether the queue is empty now. Of course it's going to be empty, but let's put our functions to use and see how it works. Okay, so we can say is the queue empty? Is the queue empty? So we are asking a question. So we'll see how our queue responds. So is empty. Okay, fine. So now we'll try to enqueue some values. So let's start with 1, and then let's say int less than 6, so that it enters some 5 values at least, right? 5 values. So we'll try to print some message as well, right? So we'll say q dot enq int I into 10, so that it looks easy on our eyes, right? System dot out dot println, and over here we say enqued. So the value that we are going to print is I into 10, right? Plus we are going to say enqued value into the q. Okay, that's it. We're done. And now we are going to dequeue it. So before that we will retrieve the size equal to q dot size. We retrieved it, and we are going to print the, let's say we'll start from 0 and less than size plus plus I, and we are going to print a message dequeued. So we are going to print the directly call the invoke that function, right? Dequeue. That's it. And we are going to dequeued from the queue, right? That's it. We have dequeued. So we have used our empty is empty function, size function, enqueue and dequeue functions, pretty much all the functions. Let's compile and see how it goes. Okay, cool. So we don't seem to have any error. Okay. So Java queue. So is the queue empty? It is true. Initially it was true, and then it enqueued 10, 20, 30, 40 and 50, and when we dequeued, it is returning in the first in first out sequence 10, 20, 30 and 40. So that ends our third part of this video. Thank you for watching this video tutorial. For more such videos, please subscribe and watch future videos. Thank you.